In June 2012, the New York Times published a headline that stopped people mid-coffee. It said, "How many computers to identify a cat?" 16,000 people laughed. It became a meme. Late-night hosts made jokes about it. The general reaction from the world was, only Google would spend millions of dollars and 16,000 computers on something this ridiculous. But here is what nobody realized in 2012. That experiment, that cat experiment, was the moment artificial intelligence became real. It was the proof of concept that unlocked the architecture that became Google Translate, Google Photos, Google Assistant, and eventually the deep learning revolution that produced ChatGPT, Gemini, Claude, and every AI system you interact with today. The most transformative technology in the history of human civilization was validated by a cat, not metaphorically, literally, by a cat on YouTube. Here is the full story. The year was 2011. Andrew was a Stanford computer science professor with an idea that almost the entire field of artificial intelligence thought was wrong. The dominant view in AI at the time was that you had to tell a computer what to look for. You label thousands of images. This is a cat, this is a dog, this is a face. And the computer learns from those labels. Supervised learning. The computer is a student and the human is the teacher, pointing at everything and saying what it is. Yang believed something different. He believed that if you built a neural network large enough, a system with enough connections, processing enough data, it would start to learn on its own, without labels, without being told what anything was, the same way a human infant learns, by watching the world and finding the patterns that repeat. He called it unsupervised learning, and the entire establishment told him it would not work at the scale he was proposing. Google gave him the chance to prove them wrong. The experiment Google. Brain was founded in 2011 by Andrew Ng and Google fellow Jeff Dean to pioneer scalable neural network applications inspired by brain-like processing. PET-MDT, the research team, connected 16,000 computer processors and trained them on a dataset of 10 million images, each 200 by 200 pixels, taken directly from YouTube videos. A brain-like neural network was then set to work on that data for 3 days straight. Meow Guide's 3 days, 10 million images, 16,000 processors, and nobody told the system what any of the images contained. No labels, no categories. No human pointing at the screen and saying, this is a face, this is a building, this is a cat. The system was on its own. After 3 days, the researchers did something that sounds simple, but was actually one of the most significant moments in the history of computer science. They looked inside the network to see what it had, decided to pay attention to, and what they found stopped them. Cold, the cat neuron, the Google brain, assembled a dreamlike digital image of a cat by using a hierarchy of memory locations to cull features after exposure to the millions of images. Presented with the digital images, Google's brain had looked for cats. Meow Guides, the network, had not been told about cats. It had not been given a single labeled image of a cat. It had been given 10 million unlabeled images from YouTube and told to find whatever patterns mattered most, and it decided that cats mattered most. A small part of the computer's brain had taught itself to recognize felines. Jeff Dean, Google fellow and co-director of the experiment, told the New York Times, it basically invented the concept of a cat. VCA animal hospitals, think about what that means. A machine, built from silicon and code, with no prior knowledge of the world. Watched YouTube for 3 days and concluded, on its own, with zero human guidance, that cats were one of the most important recurring patterns in human visual experience. It was not wrong. Cats are one of the most photographed, filmed, and shared subjects in the entire history of human media. The network was not making a quirky mistake. It was making a statistically correct observation about what human beings care about most when they point a camera at the world. The cat neuron was not a glitch. It was the system working exactly as intended, and the first proof that it worked at all. Why this changed everything. Before this experiment, the AI research community was deeply skeptical that unsupervised learning could work at large scale. The prevailing wisdom was that neural networks needed human guidance at every step, labels, corrections, supervision, or they would produce nothing useful. In past unsupervised learning tests, machines had only managed to attach importance to lower-level features like the edges of an object, but never more abstract features like faces or cats. The Google Brain experiment broke this barrier completely, demonstrating that a sufficiently large neural network could spontaneously develop high-level conceptual understanding from raw, unlabeled data. PubMed Central. This was the proof of concept the field needed. It validated a set of architectural ideas, deep neural networks, large-scale training, unsupervised feature detection that the entire subsequent AI revolution was built on. The researchers who worked on or were influenced by this experiment went on to develop the systems that became Google Translate, Google Photos, the voice recognition in every smartphone, and eventually the large language model architecture that produced ChatGPT. Google Brain's emphasis on empirical scaling of compute and data drove the widespread adoption of deep learning frameworks that transformed the AI industry. Google Brain eventually merged with DeepMind in 2023 to form Google DeepMind, now the most prominent AI research organization in the world. PetMD. Every AI conversation you have had, every image an AI has generated for you, every time a voice assistant understood what you said, every medical diagnosis AI has helped make, every drug AI has helped design, every recommendation algorithm that has ever suggested something you actually wanted to watch or read or buy, all of it traces back through a chain of research and development that has a single, identifiable turning point. A neural network watching YouTube, videos, finding cats. Here is the part that most people never think about. Why cats? Why, out of 10 million images from YouTube, did the network decide that cats were the most important thing to learn to recognize? Because YouTube, in 2012 and arguably still today, contains more cat content than almost any other single subject. Because human beings, given the ability to share images and video with the world, chose to share cats more than almost anything else. The network was not making a cultural judgment. It was making a mathematical one. It was finding the signal with the highest frequency in the noise. And the signal that human beings have produced most consistently, most enthusiastically, and most globally across the entire history of internet video is the domestic cat. The cat was not a funny accident at the edge of a serious AI story. The cat was the data. The cat was what humanity chose to document more than almost anything else. And a machine, given the chance to learn from that documentation without any human telling it what to find, correctly identified that the cat was the center of it. Andrew Ng and Jeff Dean went into that experiment hoping to prove that unsupervised learning worked. They came out with something more interesting than proof of a technical hypothesis. They came out with a measurement of what human beings actually care about, when nobody is telling them what to care about. And the answer in 2012 was the same as it had been for 10,000 years. Cats. The next time someone asks you what started the artificial intelligence revolution, what the single experiment was that proved the whole thing was possible, you know the answer now. It was 16,000 computers, 10 million YouTube videos, 3 days of unsupervised learning, and a neural network that looked at everything humanity had ever chosen to film and decided, without being asked, that cats were the most important thing in the world. It was not wrong then. It is not wrong now. See you in the next one.